Hi guys, I'm Ahmad Isa from the Garage Plus, and in this video I would like to demonstrate how I diagnose this cylinder misfire in this Nissan Tiida. So first of all, we do experience a misfire in this vehicle, and then we hooked up our diagnostic scan tool and retrieved the diagnostic trouble code. It is pointing out that cylinder 3 is giving a misfire. So next we use our oscilloscope, we use our coil on plug paddle probe to get the signal, secondary ignition signal, to our oscilloscope. Okay, and as you can see, this is the fourth cylinder ignition waveform. The burn line is pretty good. As you can see, this with refers to this, we check the other cylinder's secondary ignition waveform, and in the third one we just get a noise. Okay, so I did a power balance test. So in the power balance test, uh, all I selected all four cylinders while it was idling. Okay, and then I executed the test. So this is before I executed the test. If you So as you can see here, in this one exhaust pulse is quite dominant than the other. Okay, and then these exhaust pulse are not even, so that's why there's an engine vibration in here. And next you see, after the power balance test, when the fuel injection is cut off, you see equal amount of exhaust peaks. So here in this test, practically what I'm seeing the contribution, how tight the cylinders are. So if there's some cylinder leak or something like that, AI is going to escape from the cylinders and it's not going to give even exhaust pulses. Okay, so these exhaust pulses are even after you do a fuel injection cutoff. So now I'm confident that there's nothing wrong with the cylinders, and the cylinders tightness, it's pretty good, it's contributing equally, and then this vibration is nothing revolving around a cylinder under compression issue or something like that. Okay, so in this vehicle, since the intake manifold is above, I have to remove the intake manifold to access the ignition coil to do a swap test and to check if the problem is revolving around the ignition coil. So in this, what I'm doing is I'm checking the power, ground and the pulse width modulation here, so that once when I have the intake manifold removed, what I'm additionally going to do is I'm going to check the fuel injectors. So after I check the fuel injectors, and if the fuel injectors contribution is the same, and then after the I'll be doing an extra precautionary step to swap the ignition coils, and then I'll be repeating this test, so to narrow down as to what the problem might be with regards to this what cylinder misfire. So before I test the injectors in the test bench, I first do the service. So I install the serviced injectors in the test bench, and I can test it. Okay, so now I pressurize the injector and I check it under pressure if it is giving any leak. So there is no any tip leak here. So this is my initial test. After that I will give a simulation and check if it's injecting uniformly across all four cylinders. So now I do a volumetric test. Here I'm feeding the pulse width given by the ECU. Okay, the same, replicating the same amount of pulse width, same amount of rail pressure, and as you can see, all the four injectors are contributing equally here. So we cannot say that there's a problem with the injectors. Okay, so now what I do is I stimulate the ignition coil, and observe the spark. So I can observe a spark in each spark plug put in each ignition coil, and it's basically visually it appears to be all fine. I checked all four ignition coils like this, stimulating. So there might be a problem in the cylinder condition problem that is causing this misfire. So apart from that, I took the internal resistance to check if these are fake spark plugs. These spark plugs were given around 3.2 odd kilo ohms, 3.3 kilo ohms. It's pretty good, but the spark plug which is on the cylinder that was having the misfire, that was having around 4.5 kilo ohms of internal resistance. So these are ideally standard resistor range for this spark plug. We just don't know if it's duplicate, how, but close to the original they have replicated the duplicate spark plugs. And then this Nissan intake manifold have a intake runner. It controls the air volume for the cylinders. So it, when observing this, there's nothing wrong with this. Ideally there are people who service this intake runners. I do service it, but in this case there is no necessary need to service the intake runners. We are just going to attack the what cylinder misfire issue. I just don't want to lengthen this procedure. Okay, since now we have eliminated the doubt revolving the cylinders compression and then the fuel injection. Okay, now we have assembled it back, and now we swap the third cylinder's ignition coil to the fourth, and the fourth ignition coil to the third. Now as you can see, the third ignition coil on the fourth, it's giving a shorter burn time. Okay, once when we check the fourth ignition coil which up to the third cylinder, the burn line duration is a bit higher, so we can conclude that there's something wrong with the spark plug in this vehicle. So we took these extra steps just to confirm that the problem was revolving around the spark plug itself. We did it on the stimulation bench, but we couldn't understand as to why in this, but while installing the vehicle it is contributing to a misfire. Now in the stimulation it was giving a spark, but in cylinder condition, compared to others, the burn line is pretty short. Okay, since now the problem revolving around the spark plug is confirmed, so I was going to check the internal resistance, and I'm showing it to you guys again. So the internal resistance of the third ignition coil, as you saw, it was going for 4.6 kilo ohms. So this is the other spark plugs internal resistance, it's going for 3.6 and all those stuff. So all the other spark plugs were going 3.6, 3.4. It's just that the third cylinders, original first third cylinders ignition coil spark plug, the spark plug was giving around 4.6 kilo ohms. So those are high quality fake spark plugs. It replicates the original spark plug specification. Now this is the original spark plug, it's gained 4.6 kilo ohms, but as you can see, after I installed, you see the exhaust pulse in the second channel, the green trace, it's giving equal amount of exhaust pulses. And as you can see, compared to the last burn line duration, you see the burn line is much more increased than 1.8 milliseconds. You see equal amount of exhaust pulses uniformly throughout. So like I said guys, fake spark plugs are very hard to find. They are made to replicate the original spark plugs condition. Once when you test it, like the internal resistance and all, how you do it is you basically eliminate the doubts revolving other factors and then call out the spark plug guys. I hope this helps. Do follow for more. I'll be putting more content like this. Thank you guys.